Tesla's Optimus V3 is a humanoid robot built to work safely in homes and hospitals. Cleanliness is not just for looks here, it is critical for health. This next-generation machine is designed to keep itself spotless while operating around people all day. From advanced coatings to smart self-cleaning systems, Optimus V3 shows how a robot can stay germ-free without constant human help. Hospitals and homes demand a level of cleanliness that leaves no room for error. Medical studies show that about 70% of hospital-acquired infections come from equipment that is not cleaned properly. A robot built to help people in these spaces must stay cleaner than any regular machine. Tesla's Optimus V3 is designed for that challenge. It is not just another factory robot. It moves, senses, and reacts like a person, yet keeps itself safe and spotless without anyone wiping it down. Unlike a phone or a vacuum cleaner, Optimus V3 is complex. It has more than 200 moving joints, high-resolution cameras, and sensitive sensors, all covered by aerospace-grade metals and advanced polymers. Dust, fingerprints, and tiny airborne particles can collect on these surfaces during daily use. If dirt remains, the robot's cameras can lose as much as 30% of their accuracy, and grime in the joints can shorten the life of critical parts by nearly 20%. For a machine that may work 24 hours a day in hospitals or homes, that risk is too high to ignore. Tesla engineers already know how to fight dirt and moisture. Their cars use special ceramic and nano coatings to make water and grime slide off the surface. Applying similar coatings to Optimus V3 means dust and oil are less likely to stick in the first place. This passive shield is the first step toward a robot that can stay clean without constant attention. But coatings alone are not enough. Optimus V3 also needs active ways to remove dirt while it works. Small vibration motors, like the ones used in, could shake loose fine particles across the robot's shell. Tests from research labs in China show that vibration can remove more than 80% of surface dust with very little energy. Optimus could start these vibration cycles automatically whenever its cameras sense a blur or its sensors detect a thin layer of grime. Another smart idea is inspired by animals that groom themselves. Tesla could hide tiny microfiber pads inside the robot's arms or torso. When needed, these pads would slide out to wipe critical areas like camera lenses or hands. These combined layers, protective coatings, vibration cleaning, hidden wipers, and drying vents, allow Optimus V3 to remain spotless without daily human cleaning. This means fewer interruptions, lower costs, and a safer environment for the people who rely on it every day. Keeping Optimus V3 spotless is only part of the challenge. The robot must also work closely with people and handle unexpected situations without causing harm. A humanoid machine that lifts objects, hands over tools, or assists in patient care cannot simply stop every time something goes wrong. It needs to notice mistakes quickly and fix them on its own. Tesla trains Optimus using data from billions of hours of self-driving on Tesla cars. That same AI helps the robot understand its surroundings and react in real time. Imagine a hospital worker passing an item that weighs more than expected. If the robot senses the weight is off, it can tighten its grip or adjust its angle instantly instead of dropping the item. In a busy factory where a single minute of downtime can cost thousands of dollars, that quick recovery is critical. The ability to learn from errors is another major step forward. Older industrial robots follow fixed instructions and repeat the same motion again and again. If something changes, they fail until a human reprograms them. Optimus V3 is different. When it struggles with a tricky task, such as fitting a part with a very tight tolerance, it records the details and improves its next attempt. Over time, the robot becomes faster and more precise, much like a skilled worker gaining experience on the job. Software plays a big role in this growth. Tesla vehicles already receive regular over-the-air updates. Optimus uses the same system. If engineers find a pattern of mistakes across many robots, they can release a global update within hours. Every unit in the field benefits from the fix, creating a network that learns together. This is what makes Tesla's approach unique. Today's error becomes tomorrow's improvement. Working around people also means earning their trust. A robot that silently corrects itself might seem cold or even threatening. Optimus is designed to respond in a human-like way. If it makes a mistake, it can acknowledge it with a simple phrase such as, "I'm sorry, let me try again." A recent MIT study found that people feel more comfortable when robots communicate during errors. Nearly 70% of participants said they trusted machines more when they heard a polite response compared to those that stayed silent. All of these abilities, quick recovery, self-learning, and natural communication, combine to make Optimus V3 a reliable partner rather than just a tool. In large factories, it can cut production delays by as much as 40% compared to older robots. In homes or hospitals, it can adapt to each user's habits, improving the way it cooks, cleans, or provides care. Hygiene remains a key part of this story. Even the smartest robot must stay germ-free to be truly safe. Tesla plans for Optimus to use UVC light inside its hands and fingertips. UVC can destroy more than 99% of bacteria in under 30 seconds. After touching a medical device or assisting a patient, the robot can quickly sterilize its own surfaces before continuing work. Cleanliness is not only about smooth surfaces and shiny metal. True hygiene for a humanoid robot means stopping germs before they spread. Tesla engineers look at every part of Optimus V3 with that goal in mind. High-touch areas such as hands, fingers, and sensors may receive special antimicrobial coatings made with silver or copper compounds. These materials naturally kill bacteria on contact, adding a constant layer of protection that never sleeps. But Tesla goes further with adaptive hygiene intelligence. Optimus does not treat every workplace the same. A warehouse full of dust and oil demands different cleaning habits than a quiet hospital room. Using its sensors, the robot can measure humidity, dust levels, and even trace organic matter on its shell. If it senses extra dirt or moisture, it can start a cleaning cycle immediately or alert a human operator. In a hospital, that might mean running a UVC sterilization routine after almost every task. In a private home, it might simply schedule a quick cleaning once a week. Internal checks make this system even stronger. Tiny cameras or chemical sensors inside the body can scan for dirt or liquid that the eye cannot see. If Optimus detects something unusual, it can perform a self-cleaning sequence or send a detailed report to its owner. This proactive behavior ensures that the robot stays safe even when no one is watching. For healthcare or elder care, where even small lapses can be serious, these automated inspections build vital trust. Trust is what finally allows a humanoid robot to share human spaces. People are more likely to welcome Optimus into their homes if they know it will not carry germs from one task to another. Families caring for elderly relatives can feel confident that a helping hand will not bring hidden risk. Hospitals can count on a robot that moves from room to room without becoming a carrier of infection. Tesla's vision is bigger than one machine. Elon Musk often talks about creating millions of Optimus units over the next decade. Manual cleaning for so many robots would mean millions of labor hours and tens of millions of dollars every year. By giving each robot the power to maintain itself, Tesla keeps costs low and uptime high. A single unit that can work for hours without human maintenance is valuable. A global fleet of self-cleaning robots could change how entire industries think about automation. The story of Optimus V3 is more than a list of features. It shows how advanced materials, smart sensors, and powerful AI can come together to solve a very human problem: staying healthy. From invisible nanocoatings to warm air vents, from UVC lights to AI-driven cleaning routines, every detail serves the same goal: helping people live and work safely alongside machines. Tesla's Optimus V3 is not just another robot. It is a step toward a future where machines share our homes, hospitals, and workplaces without adding risk. If this vision of clean, intelligent technology inspires you, stay connected. Subscribe to the channel, tap the bell icon, and join us as we follow every breakthrough in Tesla robotics and the new age of human-robot teamwork.